Welcome to today's episode, where we're diving into the complex world of data integrity and the ethical responsibilities that come with developing technology. In a time when software and hardware play such a critical role in our everyday lives, it's essential to understand the nuances of data corruption, auditing, and the ethical implications of our choices. So grab your headphones and let's explore how we can create more reliable systems while keeping user dignity front and center. Let's kick things off with a fascinating yet concerning aspect of modern computing: random bit flips. These are rare occurrences where bits in memory unexpectedly change, often due to hardware faults or even radiation. While it might sound improbable, with so many devices running software, these seemingly unlikely events can and do happen. This phenomenon, known as rowhammer, can disrupt security mechanisms in operating systems. The key takeaway here is that hardware isn't the flawless abstraction we often assume it to be. Even though these bit flips are rare on modern hardware, they emphasize the need for vigilance. Just because something doesn't happen often doesn't mean we can ignore it. Data corruption can arise from various sources, including bugs in widely used database software like MySQL and PostgreSQL. Even these robust systems can struggle to maintain data integrity under certain conditions, showing that bugs can creep in despite rigorous testing and design efforts. Now think about the applications built on top of these databases. Many of them don't undergo the same level of scrutiny as the database code itself. A significant issue arises when applications misuse database features designed to preserve data integrity, like foreign keys and uniqueness constraints. This mismanagement can lead to inconsistent states, which is particularly problematic in systems that rely on the ACID properties of databases, ensuring that transactions are processed reliably. So what can we do to mitigate these risks? First and foremost, we need to adopt a mindset of trust but verify. It's essential to have mechanisms in place to audit data integrity. Auditing isn't just for financial systems, it's a necessity across all applications. By implementing regular integrity checks, we can identify and address data corruption before it spirals into significant issues. Large-scale storage systems like HDFS and Amazon S3 exemplify this proactive approach. They don't simply trust the disks. They run background processes to continuously verify the integrity of files, comparing them to replicas, and moving data around as needed to prevent silent corruption. This proactive stance is something we should all strive for in our systems. However, many systems today lack this self-auditing capability. They operate under the assumption that everything will work correctly, which can be a dangerous gamble. The absence of auditability can create a false sense of security, especially as we increasingly rely on less mature technologies. As we build applications, we must prioritize designing for auditability, ensuring that we can track and verify data integrity throughout the system. One promising approach to enhancing auditability is event sourcing. In this model, user interactions are captured as immutable events. This allows for a clear and deterministic derivation of state updates, making it easier to trace data provenance and check integrity. By using event logs and hashing techniques, we can ensure that our data hasn't been corrupted and can even rerun processes to verify outcomes. Moreover, having robust diagnostic capabilities can help us understand unexpected events. If something goes awry, we want to be able to trace back through the system to pinpoint the cause. This time travel debugging capability is invaluable for maintaining system integrity. As we navigate these complexities, we must also acknowledge the limitations of our technology. Assuming that every piece of hardware and software is fault-free is unrealistic. Therefore, regular integrity checks are paramount to identify issues before they escalate. The goal should be to implement end-to-end integrity checks across systems to minimize unnoticed corruption opportunities. Now let's shift our focus to the ethical responsibilities we hold as engineers and developers. Every system we create serves a purpose, but it can also have unintended consequences. As architects of technology, we must consider the broader impact of our work. This includes treating user data with respect and humanity, recognizing that behind every data point is a real person. Software development increasingly requires us to make ethical choices. While guidelines like the ACM's Software Engineering Code of Ethics exist, they are often overlooked in practice. This negligence can lead to cavalier attitudes toward privacy and the potential negative outcomes of our products. It's crucial to remember that technology itself isn't inherently good or bad. It's how we use it that matters. Just as a search engine can be a tool for knowledge or misinformation, our software systems can have profound effects on society. Therefore, we must embrace our ethical responsibilities and not shy away from discussing the implications of our choices. Reasoning about ethics can be challenging, but it's a conversation we can't afford to ignore. As we continue to innovate, we must ensure that our systems are not just efficient and reliable, but also respectful of human dignity and privacy. In summary, as we build and maintain data systems, we must prioritize both integrity and ethical responsibility. By implementing robust auditing mechanisms and fostering a culture of accountability, we can create systems that not only function well, but also respect the people they serve. Let's commit to being mindful engineers, aware of the consequences of our work, and dedicated to building a better, more ethical technological landscape. Thank you for tuning in, and until next time, keep questioning, keep learning, and keep building responsibly.